Greetings, Jason here from AVPro and Murideo, and today is going to be a really fun activity. We're going to be calibrating an LG 65C8 with CalMAN and their new AutoCal functionality. So before we get into the calibration, I just want to run through a few things and show you how all the equipment is set up, and we're going to go through a little demo on getting the equipment connected to CalMAN. Then we'll go through the calibration and look at the before and after results. So the first thing that we do is I'm going to be using 2 meters for this calibration. One of them is going to be the i1 Pro 2. The second one is going to be the Klein K10. The reason I'm using 2 meters is because the i1 Pro 2 is very, very accurate and it's a great meter, but it's a little on the slow side. The Klein is very, very, very fast. So what I want to do is I'm going to make a profile so I can use the Klein for its speed, but we're going to be able to use the accuracy of the i1 Pro 2. For my signal generator, I'm going to be using, of course, a Murideo 6G, and I'm going to be using the CalMAN software with the custom LG SDR workflow. Once we finish the SDR calibration, then we'll run through and go through the HDR calibration. Now, before we start the calibration, there's just a few things I do want to point out. I noticed as soon as we turned the TV on, there were some issues with it. These are the kinds of things that you're going to want to look for when you're judging a TV for picture quality. Now, first thing I noticed right away is this young lady right here. Her skin tone is very orange, and that's usually an indication that the color saturation or the amount of color is too high. If we move over to the left side of the image, this gentleman's jeans, notice how it's all black and there's no shadow details in his jeans, and there are actually some details in there. So after the calibration, we're going to be able to pull those details back out of the image. Also, I can tell the sharpness is too high. The reason I can tell is because there's a very hard line between his shoulder and the background, and he almost looks like a cardboard cutout. I'm not sure if it's going to show up on camera well or not at all, but he also has a lot of noise in his shirt, and just overall the picture is very noisy. So these are just some of the things that we're going to be able to fix during the calibration. So we already have all of the equipment that we're going to be using during this calibration physically connected to the laptop. The 2 meters are connected to the laptop with a USB cable. So is the Murideo 6G generator, and the Murideo 6G generator's HDMI output is plugged into an HDMI input on the TV. After all the physical connections are made, then we need to make the connections in the software with all the equipment, so the equipment can communicate with CalMAN. So the first thing I'm going to do is click on this first tab where it says Simulated Meter. And we're going to get the 2 meters connected into CalMAN. The first button I'm going to press here is Find Meter. Now I've got the Klein here checked, so let's click Search. And assuming we're right on the right COM port, then it should find it. If not, we just pick another COM port. Okay, that worked. We've got a green light here, and we've got the Klein K-series right here. Now we also have to connect the i1 Pro 2. So I'm going to click Find Meter again. This time I'm going to uncheck Klein, and I'm going to check all meters. Click Search. And now we have the X-Rite i1 Pro 2. And if I open up this drop-down screen, I also have the Klein. So we've successfully connected the 2 meters to CalMAN. I want to do the same thing with the source as well, which is going to be the Murideo generator. So I'm going to click on this source tab and click on Find Source. And then we need to tell CalMAN the make and model of the generator. So it's going to be the Murideo, and then of course the 6G. And then we're going to click Connect. Okay, that seems to be the wrong COM port. No big deal. I'm going to click Find Source again. This time I'm going to try a different COM port. Let's try number 4. Okay, that wasn't it either. That's okay. I could always look into the device manager and see which COM port it is exactly, but it looks like it's going to be that last one, COM 15. And that seems to have done it. We've got a green light here, and the Murideo 6G is listed. The next thing we have to do is connect the display to CalMAN. Now we've already connected the television to the Wi-Fi, and I've already connected my laptop to the same exact Wi-Fi network. That's how the CalMAN is going to communicate with the TV. So if I click Direct Display Control, I want to click Find Display, and we're going to pick LG as the manufacturer, and we're going to pick the 2018 Alpha 9 OLED, which covers the C8, E8, G8, and W8, and this of course is a C8. I also need to know the TV's IP address, which can be found in the Advanced Network Settings. So once you type in the IP address, you can click Connect. On the screen on the LG TV right now, it's giving me a PIN code. Now this PIN code is going to be automatically generated every time you try to connect. So the PIN code for this session won't be the same for another session. And now we've got LG 2018 OLED as our display. So we've made all of our physical connections. All of our equipment is now connected to CalMAN, including the TV. Now we can proceed with the calibration. Now before we get started, taking measurements, making adjustments and things like that, I do want to show you how to profile the two meters. So when I open up my meter tab in CalMAN, at the very bottom, there's an option that says meter profile. And I'm going to click on New. Now I've got two options for different meters. I've got an option to pick my reference meter, and I also have an option to pick my target meter. So in this case, because we're using the i1 Pro 2 as the spectral device, we're going to use that as our reference meter, and we're going to actually use the K10 for the calibration session. So I'm going to be profiling the reference meter, which is the i1 Pro 2, to the target meter, which is the Klein K10. So I pick i1 Pro 2 as my reference meter, and I pick Klein as my target meter. Now before I can do the profile, I do have to initialize the i1 Pro 2. So in order to do that, you can remove it from its mount, and I want to take the calibration plate that comes with it, open it up, and just simply place the i1 Pro 2 into the cradle. And then I'm going to click Initialize Meter in CalMAN. It up and just click. We know the meter is initialized. We also know the meter is initialized because if we pick the i1 Pro 2, now we have a blue circle with the number 240 in it. And that 240 just refers to the minutes. So if we were going to use the i1 Pro 2 for the whole session, I would have to do that initialization again in 240 minutes, which is about 4 hours, which is plenty of time. Should be okay. So I'm going to go back into the meter profiler, click New. The reference is the i1 Pro 2, which has been initialized. The target's going to be the Klein. Down at the bottom, there's a button that says Add Profile. We're going to click that. And we're going to rename this profile to LG 65C8. That's going to be the name of the profile. I also need to tell CalMAN what type of display we're working on. So this drop-down screen, I'm going to pick OLED, but I want to make sure I pick the LG OLED. Okay, side note, this doesn't have the LG profile in it. It just has a generic one. Okay, so we're going to click the OLED profile. Now there's two options you have for the profile. You have single pass and multi-pass. I like using the multi-pass myself. That means I can continue to use the Klein and I don't need to use the i1 Pro 2 during the session. Some people do like to do a single pass, but it does take a bit more time because every single reading that CalMAN takes is going to read from both meters. But we want to save some time here and just use the client. So I'm going to pick multipass. CalMAN will prompt me to say, prepare your X-Rite i1 Pro 2 for readings. So I want to put it back on its mount. And I want to profile this screen from the center of the screen. In order to do that, I like to pull up like a geometry pattern, something that gives me a target to aim for. So all I'm going to do here is I'm just going to rest the i1 Pro 2. You see the light collectors right here. I'm going to rest that against the middle of the screen, and I'm going to click the OK button in CalMAN. Now CalMAN's going to go through and take a handful of readings. Once it's done, CalMAN then prompts me to prepare the the Client K10 for profiling. So I want to take that profile from the same exact spot on the screen. So I have the Klein dead center. The lens hood is touching the screen, so no ambient light is going to be coming in. So I know it's ready, I can click OK. You'll probably notice how much faster that's going. That's why we like to use the Klein during the session. But we like the accuracy of the i1 Pro 2, so that's the whole point of the profile. So a few readings later, CalMAN makes an offset. So now I can take my i1 Pro 2, and we're not going to use this anymore for the session. We're going to use the Klein for the rest of the session. So I can put this over here, out of the way. Now the profile is complete. I can click Close. And when we look at the first tab for the meter in CalMAN, we can see that the meter profile down here says LG65C8, which is the profile that we just made. Now we can start the calibration, take some readings, make some adjustments, and get this TV dialed in. First, we're going to run through the standard dynamic range workflow, and then we'll switch over to the high dynamic range workflow. We'll show you how the AutoCal works. So as we're starting the calibration session, CalMAN's going to prompt you for a few things. These are going to be our targets that we're aiming for the calibration. And because this is standard dynamic range, we're going to be aiming for Rec 709 as our color gamut. D65 is always the white point. Now what we're going to do for this particular situation, because this is a pretty bright living room, for the gamma formula for the daytime mode on this TV, I'm going to go a little more aggressive. I'm going to go with a 2.0 gamma because it's a bright room, there's light colored walls, there's a window over by the front door that has no blinds. So for our day mode, we're going to go a little aggressive on the gamma at 2.0. One thing that you have to make sure you do too with the OLEDs is your test patterns. You can choose between different sizes. And for OLEDs and for most displays, we're going to use 10% windows. Luckily, that's set by default in CalMAN, so you don't really have to change much there. On the next step, we need to set up something called full field pattern insertion. And that's very important on the OLED. The way the OLEDs work is if the TV sees a static image on the screen, the TV will dim over a certain amount of time just to help prevent burn-in and things like that. So imagine you're trying to calibrate the TV and make adjustments, and you're taking maybe a minute or two to make some adjustments, and the TV all of a sudden goes dim on you. Now you're chasing your tail, and your numbers are off, and things aren't right. So we have to kind of trick the TV into never dimming, and that's what the full field pattern insertion is all about. This is only something you need for OLED or if you're going to be calibrating a plasma TV. So we want to make sure that this checkbox is enabled. Now the frequency refers to how often does the full field pattern insertion work. I have it set for 30 seconds. Now, typically on these OLEDs, the screen doesn't dim until usually after about 90 seconds or so. So I want to be way ahead of it. So I like to set it at 30 seconds. The duration is how long the inserted pattern stays on the screen. We're going to leave it up there for about 5 seconds. And then the pattern level We're going to set that to 15% or 15 IRE. This is going to be the pre-calibration view. This gives us an idea of how the TV is performing before the calibration. Now I noticed when I went through the menu, they had their TV set to the vivid picture mode. So on this screen, we're going to take some measurements and we're going to see how far off the vivid picture mode is. So I want to click the Read Series button. CalMan's going to run through the grayscale, let us know how the grayscale looks. And then it'll run through and hit each primary and secondary color. And this just gives us a snapshot of how much work needs to be done. Now what you'll notice here, there's 3 lines, red, green, and blue. And ideally, these lines would be more linear with each other. You'll notice that there's a lot of separation between red, green, and blue. And it makes this big hump through the grayscale. Ideally, red, green, and blue would be together and flat at 0. That means we have good gamma. That means we have a good white balance. In this particular mode, it's all over the place. What ends up happening with this type of scenario is white ends up being very, very, very blue. And that's common for a vivid mode on this TV. The other thing you may notice too, on the color gamut, you'll see boxes, and those are actually the targets for each primary and each secondary color. The little dots that you see is actually where the TV measured. So you notice that green, for example, is way oversaturated. It's also shifted a little bit to the left, which means it's too blue. Now this only tells us X and Y, or hue and saturation. It doesn't tell us luminance. We will see that on another page. But green's way off. You'll see that yellow is oversaturated. It's also a little bit too green. Red's oversaturated by quite a bit. That may have been probably what's causing those orange skin tones that we saw before we started. Magenta is too blue. The saturation looks to be okay. Blue probably is hard to see, but it's a little oversaturated. Cyan is oversaturated, and it's a little bit blue. So these are the things that we're going to fix so we have a nice, accurate picture by the end of the calibration. The one thing that we have to do is we have to tell CalMan which picture mode we're going to calibrate. In this case, we're going to do ISF Bright. This is going to be our bright, or our daytime mode. So we're going to pick Expert Bright. And CalMan prompts you to do a full DDC reset. This resets all of the picture controls back to factory. And it resets the direct display controls built into the TV. Okay, so now we're going to calibrate the grayscale using the built-in CalMAN AutoCal. Really all we have to do here is there's a button in the bottom right above Next that we're going to click to trigger the AutoCal. Another window pops up. There's a few parameters that you can adjust if you'd like to. You can tell CalMAN how many points you want to calibrate. We're going to do 42 today on the grayscale. It also has you put in the desired delta error target. The lower the delta error, the more accurate the grayscale will be. I like to set it to 0.5. I know this TV can do it. Anything under 1 is going to be very, very, very accurate. But I want to see how accurate we can make this TV. So we're going to go with a 0.5 delta error at 42 points along the grayscale and click OK. Now from here, because the rest of it's automated, we just have to sit back and watch it do its thing. Okay, so the AutoCal just completed for the grayscale. You'll notice if you can read the specs here, it took about 7 minutes and 43 seconds. CalMAN took a total of 156 readings. Remember we did the grayscale calibration at 45 points. So at 45 points, overall that gave us an average delta error of 0.23, which is very, very good. The other thing you may notice as well is the EOTF, or the gamma curve here, is literally perfect. Remember we set it for 2.0 for this brighter room, and it happened to track perfectly. So great job by CalMAN and great job LG. So now we're going to do the 3D lookup table for the color gamut calibration. So I'm going to click the AutoCal button. Now I've got a couple of options here, and it's all just going to be based on how much time you're going to be spending on this calibration. So SpectraCal and CalMAN does recommend, for the quickest calibration, to use something called the lightning lookup table. So we're going to do that for today. So the calibration type, we're going to open up this drop-down screen, and we're going to choose the lightning lookup table. And then just simply click OK. Okay, so the 3D lookup table calibration just completed. It took about 4 minutes and 57 seconds, which gave us about 101 readings. And the profile, the last number I saw, it was somewhere between 20 and 30,000 different points that it adjusted. So for the rest of the calibration, we're going to verify those points and make sure that everything calibrated well. The first test we're going to take a look at is the color checker. This is sort of a torture test, if you will, for the TV. We're going to generate a handful of different triplets, send them to the television, and then our meter is going to read that color and see if the color is accurate. Now the next page in CalMAN is going to be a test called saturation sweeps. I find these very interesting. Typically when you manually calibrate a TV, when you adjust your color gamut and you adjust your primary and secondary colors, you're doing that at 100% of saturation. So, when we calibrate manually, we're going to be aiming for these points on the outer edges of Rec 709 triangle, but we don't ever really get a snapshot. We don't really ever know how the rest of that color performs. So in other words, the middle dot here is white, and as you work your way out towards the edge of the triangle, you go from like a light pink to a middle red to a heavier red, and then eventually to red. So now we're tracking the performance and the accuracy of the in-between shades of red from white all the way out to perfect red, or 100% saturated red rather. And what you'll notice here when you look at the saturation sweeps test, the average delta error was a 0.6 for all of the measurements it took, which is awesome. Again, that's below 1. That's incredibly accurate. And you take a look at the CIE chart and take a look at the targets versus the little dots where the measurements were taken. Everything's pretty close to being perfect. So this is the very last page in CalMAN for the AutoCal for standard dynamic range. This is the post-calibration view. So at the end of the calibration report, we're going to be able to compare the before to the after. So let's click the Read Series button. CalMAN's going to do the same thing it did at the very beginning. It's going to read the grayscale. It's going to read the primary and secondary colors. We'll be able to take a look at how much of an improvement we actually made to this TV. So notice the grayscale. We have red, green, and blue almost perfectly flat, and they're together, which means we have D65 throughout the entire grayscale. And the color gamut, if we take a look at the primary and secondary colors, the targets are exactly where they need to be. Our delta errors for every single color, they're all below 2, which is very good. And our delta errors for grayscale are also below 2. So we made a massive improvement to this TV. We were able to get the colors much more accurate. Because we set the gamma of 2.0, we're going to be able to see more shadow details and things like that in this really bright room. So we'll go back now and we'll take a look at that first picture we looked at the beginning and see if we can see some differences just on that picture. Okay, now we're looking at the same image that we looked at before the calibration, and we'll look at some differences from then till now. Notice the skin tone. She's no longer orange, she looks normal. That's good. Before, when we looked at this gentleman's jeans, it was just all black. We couldn't see any detail. And now we can see wrinkles and things like that. Also, his skin tone is much more improved. He's no longer orange. Not sure how well it'll show up on camera, but there's also a lot less noise. And we now have a nice soft edge from each person to the background. It looks much, much more natural. It's a lot easier on the eyes. You can see a lot more detail. This is really what we're aiming for. It's ultimate accuracy. So not only are you going to notice things in normal television programming and normal movie viewing, like skin tones being more accurate and more shadows and things like that, but really at the end of the day, what's really important to us is that if I do watch a Hollywood film or play a video game or watch a TV show, I'm finally going to be seeing that piece of content. I'm finally going to be seeing that art in its most natural form. It's going to be the most accurate, and it's going to be very, 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 very close to what the director intended for us to see. Okay, so now that we know how the TV is performing after the calibration, you can click the next button, and CalMAN tells us that we're complete. So what we also want to do in this home is calibrate the HDR side of the TV as well. So now I'm going to click Calibrate Next Picture Mode. This time, we're going to change it from Expert Bright. We're going to go to HDR Cinema because we do want to calibrate the HDR. We're also going to do a full DDC reset for that picture mode. I'm going to click Next. The one thing that we have to do for HDR is change the parameters for the Murideo generator. So first we're going to change the resolution to 4K. So I'm going to say 4K, 24 frames per second. The color format can stay YC444. We're going to choose the bit depth for 10. We also want to click the BT 2020 box. And we're going to turn the HDR on to HDR 10. Now the generator is set up. Now what I have to do is change my workflow from the LG SDR calibration, which we just worked in, to the LG HDR calibration. We still have our meter and all of our hardware set up. We still have the TV set up. Nothing needs to be done there. We still have the full field pattern insertion checked, so nothing needs to be done here. First, we're going to do the HDR 10. We've already done the configuration of the Murideo generator, but CalMAN does prompt you here and tell you exactly how to set it up. Our white point in HDR is still going to be D65. And we're still going to be using a 10% window for our test patterns. We've done this once already, but it does prompt you again to change the picture mode to whichever picture mode we want to calibrate, and that's going to be HDR Cinema. And it does prompt you to do a full DDC reset. Okay, first thing we're going to do is the grayscale AutoCal. So this is very similar to what we did in HDR. I'm sorry, this is similar to what we did in SDR. We need to change the amount of points we're going to calibrate. Let's do the 20-point HDR. You could do the 42 if you wanted to. That's okay. We're just going to do the 20 today. And we're going to keep the delta errors pretty low. I'm going to keep that set to 0.5. Okay, so the next step in the AutoCal HDR process is going to be for the color gamut. So SpectraCal does prompt you here and tells you exactly what to do. It says CalMAN has a new method for creating a 3D lookup table. It's called the matrix lookup table, which is a 3D lookup table using a 3x3 matrix, using the math by reading just 5 color patches. And it says here in red, this is the only recommended 3D lookup method for HDR calibration. So that's what we're going to do. So we're going to click the AutoCal button. And instead of lightning lookup table like we did in SDR, we're going to do matrix lookup table for HDR. And then we're going to click OK. Okay, so CalMAN just finished the AutoCal on the grayscale and HDR at 20 points. Took about 8 minutes and 33 seconds. CalMAN took a total read of 156 reads to make these corrections. And now you'll notice the EOTF graph. That's one thing that's very important in HDR. It's very, very, very tight. It did a very good job. And the grayscale itself, it might not look as tight as it did in SDR, but you also have to remember the way the graph scales, it goes all the way from 110 to 90. So this is still a very tight window. So although it doesn't look great, if we were to zoom out on the graph, it would look nice and tight like it did in SDR. But this did a very good job. Only took 8 minutes and 30 seconds. Now we can move on. We're going to run the color checker for HDR. So the color checker is completed. It looks pretty good. We don't always expect ultimate accuracy in HDR because we are pushing the panel pretty hard at that point. But we are looking for an improvement over the factory positions and factory settings. So this looks pretty good. We'll move on. This is an important test. This lets us know how well the colors track in P3. And that's going to be, a lot of your HDR content is going to be in a P3 color gamut. There's the pattern insertion for 5 seconds, talked about before. Okay, if we take a look at the results, it did a pretty good job. You'll notice that each dot is at least touching the square in most cases, so that's going to mean a really low delta error. And for being HDR and for being for as hard as we're pushing the panel at this point, that looks pretty good. It's not perfect, but it's good. Okay, so now that we're done with the AutoCal in SDR and HDR, we're going to take a look at the calibration report and look at some before and after information. We can see the everything on the left side of the report is the before, everything on the right side of the report is kind of the after. So we can take a look at the grayscale on the left side of the screen, and we can see that it was a mess, of course, in the vivid mode. We can see on the right side of the screen where we calibrated it in the ISF bright mode. Everything's nice and flat, and the colors, the red, green, and blue lines are all together, indicating we have a good grayscale. The gamma on the left side of the screen, in that vivid mode, it's all over the place. It's just this really big dip in the gamma curve, and on the right side of the screen, it's nice and flat. So that means our luminance levels for each step throughout the grayscale are correct. Left side of the screen shows us our delta errors. In the grayscale, we were looking at a total delta error of 24.28 in vivid mode. After the calibration, we're looking at a total delta error of 0.92, which is very good. And then we look at the color gamut before and after. As we spoke about before, everything was oversaturated. It was all over the place. And if we look at the right graph, we can see that the color points are all on target, and our luminance errors are very, very low. And then the very last page in CalMAN just kind of goes through and gives you all the hard data, all the numbers, all the specifics, and things like that. From here, what I typically do is I'll email this report to the client so they have it. And then we'll go through and do our demonstration of kind of the before and the after with the calibration. Just keep in mind when you're doing your demonstration, I like to use movies that I'm very familiar with. And think about your 4 different levels or your 4 different parameters when we talk about picture quality. So for things like dynamic range, you know, we looked earlier at the gentleman with the black jeans, where we couldn't see any details in his jeans before, we could see the details in his jeans after the calibration. That's a pretty good example of dynamic range. You could also show something that's bright as well, like maybe a snow scene in a you know, Planet Earth type movie or something like that. Also, color saturation, we saw some major improvements there. Everybody looked kind of orange before, and now the skin tones look nice and good. Look at things like color accuracy. Look for sports teams that you're very familiar with, what color they should be. And again, you can flip between the old mode and the new mode and see some major differences there. And then last but not least, resolution. In the before, we could see that the image was very noisy and overly sharpened, and people looked like cardboard cutouts and things like that. And after the calibration, everything looked nice and clean and smooth, and nice soft edges, and everything looked nice and normal. So from there, again, email the report to the client. A lot of times they do like to have those types of things. It's probably a good idea to keep a copy of it on your computer as well, just in case they lose it. You never know. But guys, that's it. That was a AutoCal demonstration on LG. We went through the standard dynamic range in the ISF bright mode to be able to accommodate this bright room. And then we did the HDR10 in cinema mode. That mode tracked the EOTF the best, and after the AutoCal, the grayscale was great. and the color gamut looked really good too. So that's it, guys. That's it for today. We're going to go ahead and unpack all of our stuff and take a look at a couple different channels, make sure the DirecTV box is set up properly, and that's it. That's the entire calibration. So thanks for watching. If you have any questions, you can always hit us up on the Murideo Facebook page or the AVPro Facebook page. You can always check our websites for information like this and our YouTube channels for different videos. So again, thanks for watching, guys, and we'll see you next time.